All right, let's get started. So where are we with the course? How's it going? We are at the end. After today, we'll be done with our Python lessons, which is sad, but then we get to start on RNA-seq, which is what a lot of people were interested in based on your surveys. So people should be excited about that. For the RNA-seq, Nurullah Sultani is our TA. He is doing RNA-seq as his main project, or one of his main projects for his PhD, and he is going to teach the 3 labs to get some TA experience. He has taken the class, he's done this analysis before, so he's gonna lead the lab, so that'll be fun. I'm gonna do lectures on Wednesday the 24th and Monday the 29th. On the 31st, unfortunately, I can't be here. My PhD student is defending, and the only time we could schedule it and get him done in time to graduate this fall was that afternoon, which is super unfortunate. But lots of people in his committee have lots of conflicts, so we had to schedule it then. So I'll work with Nurullah, and either he can give a short lecture, or I can try to do more of the lecturing the first 2 days, and then he can do all lab on the 3rd day, but we'll work out something. But I will not be here on that day, just so you know. I'll also not be here on November 5th or November 7th. I feel bad I'm missing 3 straight classes. I'm serving on a USDA panel and reviewing proposals for 4 straight days. And I thought it was a good opportunity despite missing class. So Bode Olukolu will come, and he will be talking about variant calling. Fantastic bioinformatics professor. So hopefully you'll enjoy that. I will get Bode to give me some review, kind of what do you need to know from his lectures. And I will include a couple of questions on the test. But I will make sure you have a test study guide by the end of the RNA-seq lectures. Even though I won't be here, I'll make sure that that's posted online, and get Bode to give me a few key points from his that we can add. And then we'll have test 2, and then it'll just be projects. Yay. Project proposal due on November 5th. So don't forget about that. There's a description in the syllabus. It's just a one-page breakdown of what you plan to do, what tools you want to use, just a real general description. Where are you going to get your data? So if you don't have data, or you're not sure what you want to do and you want to ask me, feel free to go ahead and do that. Yeah, I think that's everything. Any other questions or concerns about the schedule? All right. Okay, so we started on conditional tests last time. I think we just saw a real quick if-else at the end of class. And the rest of the chapter is super basic, and you can go through it, but I thought instead of doing following along with the chapter, we'll just write a script that does something a little more useful instead of following along with what the book says. But the book is certainly a great resource if you're trying to figure out, what the heck I'm talking about later on. And then we're going to start on regular expressions, which I'm super excited about because they're pretty much my favorite thing ever. I actually have my husband bought me a t-shirt that says I know regular expressions. So kind of a regular expression geek, so I'm excited about that. And then somebody, Annie, had emailed me and reminded me that there's a really cool website called Rosalind. And I had done some of these problems a few years ago and I've completely forgotten about it. But if you want to keep going with your Python after today, this is a really nice community to get involved with. This has actually changed since I've seen it. And they've added all this new stuff that I'm going to have to go check out. I don't know what the textbook track is. But this is what I remember doing, which is basically you go through these problems and they start super simple and they get harder and harder and harder and harder. So that you learn over time, you learn how to program, and you also learn how bioinformatics algorithms work. And you basically learn through creating them yourself. And once you log in, I think you can see the solutions and see how other people solve the problem. And it's just a really cool little website. I sent this to my lab as well, and we are currently batting around the idea of maybe doing an independent study next semester for 1 credit hour where we could all get together once a week and just work through Rosalind problems, because I feel like that would be fun, and you can learn a lot about bioinformatics without like a lot of time on my part, to be quite honest. And my lab's super excited about doing it. So something that we could offer as a 1 credit hour. If you would be interested in that, maybe shoot me an email or let me know. We're trying to, yep. That would be next semester. I think we could go ahead and get it on the, we'd have to get it on the books in the next couple weeks, and it would be listed in one of those like non-course numbers, like 596. It's like not a number for anything. It's like a catch-all number, but I think it could be fun. And I've got some undergrads that are a little bit interested in learning more about Python, so we might include them. So maybe a 400, 500 or a 500, something like that. But yeah, that could be fun. But even if we don't do that, you should consider doing it on your own. Because it's kind of like if you're the type of person who likes doing Sudokus or crosswords, like they're just nice little fun like problems, very bite-sized. So that's nice. Oh, where did my mouse go? Oh, there it is. Okay, so let's go ahead and get back into some Python programming here. I am just going to go ahead and open 2 windows and log into both at the same time. That's better. Oh no. Okay, so I'm going to go to the course project. And just give myself a clean working directory. And then for both, I'm going to go ahead and do module load Python 3.6.1. Now, if everyone will try to copy this blast file, it's in software. It's called blast.txt, and let me know if you have any permission problems. Okay, so that is your copy command. And if you go ahead, you should see some information. It looks like this. All right. Okay, so I'm going to do that here as well, so we'll have that to refer back to. And then here, we'll call this, what are we doing? We're doing if, else, elif. Call it elif dot practice dot py and not vi. Okay, so I want to use this as kind of a practical example of something that you might actually want to do. we haven't learned enough to do something you couldn't do outside of Excel, so this will be something that you could totally do outside of Excel, inside of Excel. But it'll show you, you'll start to see how to use these conditional statements. So let's revisit if else. So let's say that you wanted to divide this file up into blasts that had an e-value over or more significant than 1 e to the negative 50, and blast results that had an e-value that were higher and therefore less significant than that. So the first thing we would want to do is tell our program where to find the file and open that file up. And then to make sure that we're doing what we think we're doing, we'll go ahead and do a for loop and parse through it and just make sure that everything's working the way we hope. Okay, so I've just got a very kernel of a program, and I'm going to run it on the bottom and see if I get what I expect. And I do. It's printing out each line of my file. So I successfully told the file what the name is, opened it up as an object, and iterated over the lines one by one. Okay, so the next thing we want to do, did we do split in here? Did we do the command split? I think we did. I can't really remember. It all blurs together. We've been writing some Python scripts in the lab too, and so like I can't remember what we've done in here versus what I've done with people in there. Okay, so I think we've done split, but let's see how that works again. So I'm gonna create a list called fields, and what I wanna do is get each one of these little columns. If you imported this to an Excel spreadsheet, they would all be individual columns, and I wanna get them into individual objects in a list. So there'll be strings, so individual strings in a list. So fields is what we're gonna call that list. Okay, and we are going to split it on the tab character. Now this is the example way back when we did blast. We learned that there's multiple types of blast output, and this is the one where you choose that it's tab delimited. So we know that there will definitely be tab characters in between all of our fields, and we know in Python our special character, how we tell Python tab is a /t. So I'm taking the line, I'm splitting it. Everywhere there's a tab, it splits it into a different string piece, and then it makes a whole list of those strings called fields. And then I'm going to print fields to make sure, again, that we're getting what we think we're getting. So this is great. This is working. We know that each field, now we're printing each list. The list is each little item that was in between a tab. We will note that our very last item does have that new line still attached to it. If we were concerned about that last item, we would probably want to go strip that off. You remember we had the rstrip command, you can strip off the new line. We're actually concerned about this e-value is what the example is, so I don't really care if there's a new line hanging out in the non-e-value column because I'm not going to use that column. Okay, so the next thing we want to do is how do we get to the actual e-value that we want? We've got it in a list, and we remember that things start getting numbered by 0. So, you know, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the 10th column. Does anybody remember how do you select an item from a list? Louder? You guys said stop to say it louder. Yes, the index. Square brackets, yes. Cool. So if we print fields 10, so this says print only the 10th item in our list. For each line, split it up and print only the 10th item. I'm going to save that and run it. Yay, e-values. So now we've actually got a little kernel of something that's kind of doing something we want. And the goal now is to use our new conditional knowledge to separate this into above or below 1e minus 50. We learned if is less than 1e minus 50. We'll say print. Okay, now we're just gonna see if this works, and it does not. Okay, so we've talked about comparing, no, we've talked about coercing items to be different types of items. So previously we've seen how to convert a number to a string so we can print it using str. We've also seen how to convert a string to a number very briefly last time using int. And now we're gonna talk about how to convert something to a float. So way back when I introduced Python, which feels like longer than 2 weeks ago, we learned about all these different types of things. And float is when you want to use numbers that have decimals or that are in scientific notation, it's called a float. So what we have here is that Python took this line as a string, it split it up by tabs into little pieces of strings, and now I'm trying to say, is this string less than this number? And Python is saying, I do not know how to compare a string to a number. But we're pretty convinced that this should definitely contain a number. So we are just going to coerce it into a number. And say, treat this bit of string like it's a float. Turn it into a decimal-based number. And this should work fine because floats recognize the scientific notation with the E. So this is actually like a good error, right? Not supported between instances of string and float. So it's telling you I'm trying to do an operation and I'm trying to compare a string and a float and I don't know how to do that. So that's how you would read that error and figure out, okay, it thinks this thing is a string, I need to change it to something it knows how to do comparisons between. So let's see how that goes. All right, so we still have our print up here. So it's gonna print it and I'll say, yes, 4e to the minus 158 is definitely less than 1e to the minus 50. Let's see, there's a more than. 4e to the negative 7 is more than 1e to the negative 50. So at this point, we are able to determine if something is above or below a threshold and do something with it based on that. One of the things that we could do here is create two different files. We could create a file called blast more than 1e50 and blast less than 1e50.txt and spit this text out to those two files. Do you want me to do that? Do you remember how to spit text out to files? Would that be helpful? Yes, okay. So what I would do, so I conveniently named these iFile and iFile object because I wanted to remind myself that those are dealing with input. When I deal with output, I like to use ofile. So we'll call this ofile less than. And we'll do something, yeah, we could call it, maybe I should just be more explicit, less than 1e50. I don't think it's a great idea to put a dash in a file name. I'm just gonna shorten it to 50. So remember, for output files that we want to write to, we have to give it that second argument of W to make sure that it's available for writing. So now we have 2 files. I'll try to keep as much of this on the screen as I can. I like to put lots of spaces in my programs to give it like kind of some logical, like these 2 lines go together, or these 2 lines. But for the sake of, you know, trying to keep as much of it on the screen as possible, I'll get rid of those spaces. I think it's a little more readable when you have the extra new lines, but okay, so at this point, we know this for loop is working. We can get rid of this. And now instead of printing, we want to write. So this is our less than. Let me go back up and remind myself. It's O file less than OBJ. And this time, maybe we want to write the entire line and not just the E value. Oh. Was that too fast? Do I need to go back up? So we're setting up the name of each of our 3 files. And you could do this, you could do like 3 names and then open them all. But I did like create the name, open it, create the name, open it, create the name, open it. But you, as long as the name variable is set before the open gets called, it'll work. Oh, you know what I could do? I could probably try to make these parallel like this. Okay, that's big enough. And then get this one. I could put them side by side instead of long ways. I tend to like them long ways because lines of code get long, but we'll see how long we can make this work. Okay, so now when I run it, I get my more or less thans, but also if I do an ls, I have 2 files. I have my blast greater than 1E50 and my blast less than 1E50. Let's open that blast less than 1E50. So when I look at this file, all of those E values, which is the next to last value in each line, it should be less than 1E50. And in this case, we're seeing, make that a little, -58. Our zeros got handled correctly. Our -62, -115. So just by glancing through, it looks like that we were successful. And we can also check our greater than 1E50. In this case, we've got fewer, but 12, 11, 12, 7, 27. Indeed, all of our E values are greater than 1E to the -50. So our little script to separate our files has worked. Could you do this in Excel by sorting and cutting and pasting? Yes. But we're starting with small examples so you can see the power. All right, so the next thing we could do is learn about ELIF. So sometimes you have more than one, like your decisions aren't binary. Like what if you wanted to say greater than 1E, less than 1E, and exactly 0. So we could add another point here. So if float fields 10 equal to 0, no, do not do that. We will print exactly 0 but then my exactly zeros, if I continue down this route, this will actually work. But my exactly zeros will also go into here. I don't, because it'll go through this if and say, is it exactly 0? Yep, print it out. And it'll get to the next if. Is 0 less than 1e to the minus 50? Yep, print it out again. And we don't want it to do that. We want to say, if it met the first condition, skip the next one. And there's a construct for that called elif. So that's basically saying, if it's this, do that and ignore the rest. If it's not that, if it's this, do this next little part. If it's not that, then go to the else statement. And you can have multiple elifs. So it's kind of giving you like more chances to continue to make decisions about your data. So if it's 0, it should get printed here. If it's not 0, but it's less than 1e to the negative 50, it should get printed here. And if it didn't meet either of those criteria, it should get stuck here in this block. So now our exactly zeros are being printed as exactly zeros. But our less than zeros, they're not also being printed as less than 0. They're getting picked up in their own block of code now. So now we have a three-way sort. So if you had to sort this into lots of different partitions, you had some file and you needed to create 10 subfiles based on whatever random ranges of numbers you need. This is one way you could go about doing it. And we could go up and add, and I like to do things iteratively. Like notice that I'm like building a couple lines and then we go test it. And then we go build a few more lines and then we go test it. It makes it much easier to debug that way because you know that you have something working and you add a couple lines. If it fails, you know what you did is what caused the failure. Instead of if you add like 10 lines and then it fails and you have no idea why it failed, because it could be any of those things you added. If you do it in like these little small incremental pieces, that's a better way to write code, and it'll probably make you faster, even though it feels slower because you're like checking it every few lines. But now we could open another file. Oops, I'm getting ahead of myself. And now if we look at our blast equal to 0, all of our e values, which are off in there, 0, 0, 0, 0. So we were able to sort this file into 3 sections based on the e value. And now you know if, else, and elif, which are all great things to know. You can also, what would be a good way? Okay, what's another good, okay, I think this is percent identity. So another thing that's in this chapter that I haven't taught is using and or. So the percent identity is gonna be field 2. So let's see, what if we only wanted to print files that the percent identity was over 80%? You can add something like and float fields 2 is greater than 80. Make that a little bigger. So now, and you can use the keyword and, all lowercase, or the keyword or, all lowercase. And it's gonna say, so now to meet this if the float for fields 10, which is essentially the e value, is equal to 0, and the percent identity, which is the float that we're creating from field 2, is greater than 80%, then we wanna write it. So let's check these. This is 52%, 70%, 87, and 83. So we expect 2 of our 4 to get retained with this and. So let's run it. And now we only have 2. So ands and ors can also be used as part of your, you want to make complicated statements like this and this or that, you can use parentheses to group them just like you would in a normal logic way. Click on this. There's writing. Yeah. Does that kind of make sense? Oh, and it's worth noting here, because I opened those files for writing, when I reran the script, it completely overwrote our original output. If we had put A instead of W at the top, it would have kept adding output to the file. But since we put a W, it said, there's a file there. I don't care. I'm just going to write on top of it and get rid of it. So be careful when you're opening files for writing something with a script, because it will just get rid of the old version. It will not tell you there's an old version. It will not say, are you sure? There will be no undo. So you have to be cognizant of that, or bad things can happen. Any questions about that? All right. What else was in that chapter? We're not going to worry about while loops, because you can do pretty much everything you need to with for loop, I think. Yeah, for the most part. Yeah. Okay. Regular expressions. Yay. Okay, so I'm going to move everything to my hide folder again, so that we just have a clean directory. Okay, so regular expressions can basically boil down to searching for patterns and strings. Most programmers, not most, a lot of programmers do not care about regular expressions. It's not something they end up dealing with very often. But as biologists, it turns out that you will use these all the time. And this is how I got really good at them, because in biology, it just turns out like this is a super common thing you need to do, look for patterns and strings. Given a DNA sequence, what's poly A tail would be an example. Given a gene accession name, extract the part between the third character and the underscore. Given a file in a certain format, you need to there's variable number of spaces, and you need to get rid of the spaces and rearrange the columns and move this thing over here and rename this thing based on a pattern. I would say it's mostly dealing with file formatting. But all of these are examples of things that you can do with a regular expression. So it's very convenient. You think? It sounds like yeah, okay, anyway. Very weird noise. Okay, so for us to learn about regular expressions, we have to learn a little bit about modules. So when I first introduced Python, I mentioned that it has lots of libraries to help you import functions from other places. So somebody will come along and write a library and say, I have to write all this code that knows how to deal with matrix math. I'll just publish it and make it this nice library of functions that anybody in the world can then import it and use it, and now it's called a module, and anybody in the world can import it and now access all those functions that somebody else wrote for matrix math. So that's the power of Python and really big languages that have lots of programmers, is that lots of people are publicly contributing modules that do things that you would be interested in. Okay, I'll turn the volume way down low, but hopefully you can still hear me on the video. We'll see. Okay, so to import a module, you use the import statement. What am I doing? Okay, so the first thing to not do is do not name your module re.py. It will try to import itself if you name, so module is named the module name .py, and then when you import it, that's the name of the file it's looking for. So do not name it that. We're going to call re practice. And our first statement is going to be import re. And this is at the top of the program, and it basically just says, go find the regular expression module, which I am sure exists on the ACF. I don't think I tested it, so we'll find out, but it should be there. If it's not there, you'll generally just get an error saying I can't find this module, and then you have to go install it. which you can do with something called Anaconda. I think we're going to do some of that with the RNA-seq workshop, but if not, you can always also just email the help desk at ACF and ask them to install it for you. So the other thing we need to talk about before we do too much with this is raw strings. It's easier to deal with strings, with regular expressions, if you use this raw string paradigm. So lots of characters have special meanings in Python, like the /new and the /t, except there's a whole bunch of them. And if you put an R immediately before the opening quotation mark, then any special characters inside the string are ignored. So let's see that. We'll do S, quotes, and S/n, S. Yeah. So up to now, this is very much in line with what we have learned. We're going to print the character S. We're going to print a tab. We're going to print another character S. We're going to print a new line, and then we're going to print another character S. See that? So, indeed, we got an S. We're pretty sure that's a tab because we got a number of spaces. We got another S. We got a new line, and then we got an S. But if we go back over here and we put an R outside the quotations, but right before they start, this forces Python to interpret this as a raw string. Now if we run it, it does not, it ignores our special characters. So that's just gonna make regular expressions behave a little bit more rationally. Note the R is outside of the quotation marks, not inside. It's on the outside. It always has to be at the front. So methods from a module are kinds of like when we learned methods earlier, that they have to be attached to a thing. But this time we are going to attach it just to the name of the module. So I'm going to get rid of this. No, the functions have to live in a document, and you can, yes. So if you just put import into your Python program, that will not work. But you can go into, Python comes with something called pip. You can say pip install RE, and it will install regular expressions. Caveat to that is you don't have root permission on the ACF, so you can't actually do that. So then there's this other package called Anaconda that allows you to manage your own environment, and you can say, Anaconda, you create an environment, you install the modules that you care about, and yes, it will go get it from the cloud, from the internet, wherever they live, from PyPy, which is the Python package index, and we'll download it to your computer. With Anaconda, you can force it to do it in your home directory. You don't need root permission. You don't need admin permission on the ACF. But none of that, you're not going to do any of that inside a script. You're going to do that on the command line. And sometimes it's easier to just email the help desk. If Python is something you're going to get super into, it's something that you're going to want to just go ahead and do a deep dive on Anaconda and learn how to use it. Like I have an environment on my laptop where I type source activate biopy, and it make sure that when I type Python, I'm getting Python 3, I'm getting BioPython libraries that I want, I'm getting the pandas libraries I want. Like I have this environment set up where it like loads everything that I want, and then it just kind of works. But setting all that up takes a little while, so it takes a little bit. You got to learn a lot about Anaconda. So if you're going to use a lot of packages in Python, I would say it's worth it. It's also nice because if you have some packages from Python 2 and some from Python 3, you can maintain two environments. You switch between them on the command line, like super easy. Like source deactivate, source activate, Python 2, and all of a sudden you have your Python 2 set up with all your modules that you want. Are there speakers in here? Anyway. Yes. I'm sorry, it's kind of driving me insane. I don't know. Anyway, okay. Well, I'll just have to try to put up with it. It's just very weird. So does that sort of answer your question about modules, Daniel? Yeah? Okay. Yeah, so this will be our first module. Let's leave this. What we're gonna do, we wanna use the search function as the function that we're gonna start with on our regular expression module, but we can't just type search, even though we imported the module. We have to tell it that we want the search from the regular expression module. We'll do re.search. And let's set up a variable that we can work with here. Okay, so inside our search, our first argument, and we're always going to use these raw strings when we do anything inside of a regular expression. So search takes two arguments. The first one is what we want to search for, and the second one is what we want to search on. So this is saying we want to find GAATTC inside of the variable DNA. Conveniently, these strings lined up perfectly, so it's very easy to tell that this should definitely work. And so let's just turn that into an if statement. So we're saying if this returns a true value, let's print restriction site found. Okay, good news. RE exists on the ACF. And second good news, we found it's working. Our search worked, and we were able to find what we were looking for. Let's say if we change this to 3 A's, and we tested it, we did not get that to print, so the if failed. So there was definitely, the search is working. This is not a super useful function. We already learned a function that will essentially do this exact thing. You guys remember what it was? Find, yes. So find will find an exact string for you. It's very convenient. Regular expressions is something you really only want to use if there's some variability in what you're looking for. So an example might be the AVA2 motif, which is a restriction enzyme that cuts at two different motifs. It cuts at GGACC and at GGTCC. So one thing we've already learned today, let's read GGACC or GGTCC. So now if it passes either one of these two conditionals, because we used an or, if either one works, we should get restriction site found. GGTCC, I don't think either one of those are in there. Let's find out. Nope, neither one was in there, but let's see if we added it. Now restriction site found. However, I promised you that we would learn how to do this in a much more elegant way. Instead of, again, you could just do this with a find or another find. But we have a way to say alternation, this character or that character inside these regular expressions. So I'm going to get rid of one of these because we only need one. Now I'm going to say, for this T, I'm going to say I will accept an A or a T at this location. So the syntax for that is to wrap these things in pair parentheses and then say A or T and use the or that's like the tall, skinny bar on your keyboard. And we can prove to ourselves that that worked, because right now it's meeting it with the GGACC, but if we change this to a T, it should still work. And indeed, it still works. We could also say, hey, what if we would accept any base at all in that position? You could keep adding other characters. Oh, and now if we changed it to a G, it works. You run the correct Python script that works. There's actually a shorthand for this. Regular expressions are all about memorizing syntax, but the shorthand for this is to use square brackets. If you square brackets, you don't have to put the ors in. So this is called a character group. So this is saying I want a G followed by a G. I will then accept a G, a T, a C, or a G. And then I want a C, and then I want a C. That's my pattern. If you can find that pattern, return true, and let's say that we found it. There is also a way to say I'll accept any character. That's with a period. So if you were actually trying to search for a period inside your string, you have to do this. But let's, for right now, and I'll show you that in a minute. But right now, a period naturally just stands for any character. So let's run this. Okay, so that worked because it found a G and a G. It found another character of any type and then a C and a C. But we could put anything here. We could put a $sign. Now say, yep, $sign's fine. That's a character. I'll take it. We can put a space. Yep, that's fine. Space is fine. We'll take it. It's a character. If you want to match, and it will actually match a period because a period is any character as well. But if you wanted to match a period and only a period, you have to escape the period. You say, don't treat this period like any character, treat this period like a period. And then it still works, but now if we change this to, let's do A, now it won't work because it's saying I'm looking for a G, a period, a C, and a C. It can't find that. There's no periods in this string, so it won't return. But if I come back over here and change this back to, now we're back to GG, any character, CC. We can also quantify the exact number of times that we want to see something. So a question mark is for 0 or 1 times. So I could say, what would be a good example? Let's put an A here. So I will take a GG, an A 0 or 1 time, so either no A or 1A, and then a CC. And that should match because we've got GG, A, CC. It should be anything else, please. This might help. Okay, so we learned, this is the one that's really fun. I'll try to make I'll put it up on the course website before the next period. So we've learned alteration with the or, the parentheses in the or. We've learned character groups with the square brackets. We've learned the period, and now we're learning quantifiers, and there's 3 quantifiers. So this one is a 0 or 1 time, so this should still work even if I get rid of the A. Oops. Because that is a 0. So 0 or 1. A plus means 1 or more. In this case, it's not found because we don't have an A in there anymore.
Can you find like a deletion?
Can you find what? A deletion? Not if you didn't know what was on the other side of it. Like what would be your parameters for deletion?
That same way you look when deletion.
So you're saying if this text is not there? Yeah, so we could just say if RE search, if not RE search, if I don't find that, if I don't find GGACC, then print that site has been deleted, right? Okay, so let me finish with plus and then we'll see an example of that. Okay, so now I've put in 3 A's. And it works fine because it's saying I will take A 1 or more times. So you could go in and put like lots of A's. We'll say, yep, I like it. As many A's as you want. Okay, so now if you wanted to say, is something missing? So that's going to be found right there. So it should print. Site found, and then if we go delete it, it prints site deleted. You have to know regular expressions depend on you to tell it what you're looking for. It's not smart enough at this point to say, if you don't know what the deletion looks like, you can't write the regular expression to know. If you knew like the flanking parts, you could say, I want to see this and I want to see this, and they can't be more than 1 character apart. I know that's a deletion. You can write that, if that makes sense. Okay, so we learned the question mark is 0 or 1 times, the plus is 1 or more times, and then the star is 0 or 1 or more times. So the star means this character can be here not at all, once, or a million times. I don't care. So get rid of all this. We're going to use a star. You can also put these guys in a parentheses and operate on, like, I want to see like a T star number of times. So at that point, you could have like that. So I will accept a GG, and then I want an AT 0 times, 1 time, or multiple times, and then a CC. And you can put any length of anything in here. So this actually turns out to be really nice. We have a whole, a really ancient Perl script in my lab that we still use all the time when people are trying to design simple sequence repeat binders or ones SSRs. And we'll run it and it'll find like every possible SSR in a DNA sequence so they can design markers. And we do that all with regular expressions. And to make it more sophisticated, let's say you know for your marker that you only want ATs that are repeated between 4 and 20 times. So this works because there are 1, 2, 3, 4, 5. But if I got rid of a couple, no, it's not going to work because, oh, when did it work? I hate it when that happens. 1, 2, 3, 4. Okay, there's still 4. And we have 3. It doesn't work. There's only 3 copies. And if you had like one that was 50 copies, you were like, that's too long. I can't design primers around that. So you can limit your like only more repetitive regions that are a certain length. That's how you do it. And you can do that for a single character as well. So if you just had 420 for all those ATs. This would not work because there's only 3. As soon as we add a 4th, it works. So only return if you have a G between 4 and 20 A's, and a C and a C. Okay, what if you knew you wanted only sequences that begin with ATG? That's a good one because you're like, I only want things that have a start codon. Caret anchors your pattern to the front of the string. That's saying, I only want you to return strings that have ATG as the very first 3 letters. Nowhere else. I do not care about anywhere else in the string. In this case, we would probably say start codon bound. So here's the start codon has been found, but what if there was an extra A? That shifts our whole open reading frame. No more start codon. So now it will not return start codon found. So carets anchor you to the front of the string. The opposite of a caret to anchor you to the end of a string is a $sign. TGA, is that a stop codon? I think that's a stop codon. Oops. Okay, so in this case, we're looking for strings that have TGA at them. This one does not. So it does not return anything. So if we add TGA, oh, still didn't work. Oh, sorry, I put the $sign in the wrong location. TGA, $sign. So caret at the beginning to indicate the beginning of the string, $sign at the end to indicate the end of the string. This is the problem with becoming a faculty member. You don't get to sit down and do your own research and code anymore, and you start forgetting things. It's very scary. I used to be able to do this stuff in my sleep, and now I'm like, oh, I haven't coded in like 6 months. Yeah, those are super useful. What are some of our, see, it's also scary that I can't remember all the stop codons. Anybody know what the other stop codons are? TGA? TA? TAA. Okay, so this is saying I want either TGA or TAA to be at the end of my string. And if it satisfies that, print stop codon found. And that will work with TGA. Let's try with TAA. And that works. And now if I add some random character like a G, it doesn't work anymore. Yay. So yeah, regular expressions are all about syntax, and like usually you see them and you're like, I have no idea what this is doing. And there's like parentheses and brackets and stars and carets and $signs. You're like, what does this mean? But over time you develop this like ability to kind of see the pattern and decipher them, and they turn out to be super, super useful. These have a lot of really, these are used a lot when you're filling out forms on the internet. So let's say it asks you for your phone number and you only type in 8 numbers. It's going to say, nope, that's not a valid phone number. I need 9 numbers. Or you type in your zip code, and it has either, and it'll say, okay, well, I'll accept a 5-digit zip code or a 5-digit dash 4-digit zip code. Systems. So lots of these like form checking when you're like filling things out and it's like telling you, no, you didn't enter the right thing. A lot of that's like backed by a regular expression logic. So useful in real life too. Or is it, that's not a valid email address. I need to see a word and then an @ sign and then another word and then a dot and then a 2 to 3 letter code. And that's how you check for legitimate email address. It's formatted correctly. Whether or not it exists is another story. Yeah. Yes, we're going to do that next. Okay, we can skip combining. Yes. Okay. Extracting the part of the string that matched. Let's do that next. So let me get an example going here that's going to work with GACGT. Hopefully that worked with the rest of my examples. Okay, so now we're going to create a variable called m, and we're going to store our match. Instead of using it as a true false, we're going to store the results. Oh yeah, Control K. Okay, so we're taking our restrictions on search function. We're saying find a GA, and I want any of an AT, C, or G 3 times, and then I want an AC. Just by I, it looks like we've got a GA. We've got a series of 3 bases that meet our criteria of AT, C, or D. Then we've got an AC. So this should match. But what we're going to do is print the part that matched. So it's going to tell us, so let's imagine this was thousands of bases. You had no idea if this pattern existed, and you definitely didn't want to read through that whole chromosome. This will tell you, yep, I found it, and this is the exact sequence that matched your pattern. So yeah, let's combine, we can actually search for multiple patterns at a time. So let's do something more complicated. So after the AC, we want to get, I'm gonna wrap this in parentheses. And then I'm gonna start another set of parentheses, ATGC. I wanna see 2 more nucleotides and then an AC. I have all my parentheses right here. These take a long time to write to do it well. So I want a GA, and then by wrapping it in parentheses, I'm saying I want you to store whatever matches this AT 3 more nucleotides. Then I'm gonna have another AC, and then there's gonna be 2 nucleotides, and I'm gonna have another AC. And for my matches, I want to store those 3 nucleotides, and I'm going to store these nucleotides. I'm going to wrap a part of a regular expression in a parentheses that's storing it for you to access. If you want to match an actual parentheses, you would have to escape it. But for the most part, at least for nucleotides, we do not expect there to be actual parentheses in our strings. So we're not, okay, we're not going to worry about that. Let's say we still get the entire match. Okay, so the entire part that matched was this GA-CTG, AC, GT, AC, right? So that matched GA, 3 nucleotides, AC, 2 nucleotides, AC. The whole thing is returned by M that group. This first set of stuff in parentheses that matched is the CGT. I was between the two hits that we had as, you know, they definitely have to be GA and definitely has to be an AC. And then that second group that we wrapped in parentheses is GT, which was in the middle right there. Does that kind of make sense? You can capture like different parts of the pattern by using parentheses. And yes, you can get the actual position. Let's see, where am I? Okay, let's try that. So our match is from index 2 to index 13. And we can get the start and stop for each individual subgroup as well. No. You have to convert everything to strings because it returns integers. And then our submatch is from position 4 to 7. So from 2 to 13 is the entire match. And then 3, 4, from there is the CGT, 4, 5, 6, 7. And remember, inclusive at the start, exclusive at the end, count starting from 0. That's how you figure out your indices. And then you can do the same thing with strm.start2 and strm.end2 to get the start and the end of the second subgroup. So what if we wanted to find multiple matches? That's a good one. Let's say we want to find AT-rich regions. That's a good example. So we'll just have some normal kind of complexity sequence, and then maybe we have some random AT-rich region, and you know, some more kind of normal complexity, and then another. Okay, that got kind of long. You guys don't have to type all of that. Just bear with me. You can use the find all command. And in this case, we might want to say, I want a set of A's and T's that span from 4 to 100 bases in length on that DNA strand. So either A or T, a run that goes from 4 to 100 bases in length. And I want to find all of them. And that returns a list. It gives us our 2 AT runs. And I forget how to get the start and end of a list. There's a way, but I forget what it is. Oh, yeah, you would probably not use find all. If you wanted to get the indices, you would use something called find iter. Yep, that's exactly what you would do. Okay, let's try that real quick. Okay, find iter stands for find iteration. I shouldn't have deleted that because it's pretty much the exact same regular expression pattern. And we're going to use a for loop. Okay, so in this case, we're going to say the run start is matched at start, or matched at start is we're going to take that value, we're going to store it in a variable called run start. We're going to take matched at end, store it in a variable called run end, and because we're iterating over the list, we'll get this for each and every match, and then we'll print AT region is from the start to the end. I think I have all my parentheses all sorted out. We'll see. So AT rich region from 9 to 21 and from 33 to 47. So that's how you would get your indices for your group matches. Questions? It's very powerful. Yeah. People will come, like I work with grad students a lot who are trying to reformat files, and we end up using a lot of regular expressions to reformat files into the correct, get everything in the correct order and change the names of all the genes and stuff like that. Okay, so let's see a real quick practical example. Go back to our BLAST file. Oh. So I stuck my BLAST into a hide folder because my Python practice directory is accruing a lot of random files over the course of the past 4 class periods. What if we wanted to capture just this part and get rid of the SP or random set of accession, random accession, and then the OR? We could do that. Okay, so we always start by setting up a super basic program, right? We know our file is called blast.txt. And we're going to want to iterate over it. For line in. Oop, I already see a problem. Call this blast. Sorry, practice. Okay, so we're now able to print every line in the file. Now to use regular expressions, we want to import RE. This is going to be kind of complicated, so just stick with me. I don't expect you guys to know this. I just want to give you an idea of like the depth of complexity that you can get to and sort of the power that you can get to. So let's search. We are going to search for SP, the or sign, some letters, another or sign. That's going to be our search string. I know for a fact the or is used as a special character, right? Because we learned in that A or C example, that very first regular expression example, that regular expressors consider the bar to be a character that means or. We wanted to ignore that and just and actually look for the bar in our line. Oh, no, yeah, so I want to search, and actually let's just go ahead. We'll just do all ones. Something called replace. I'm gonna take that, I wanna replace it with nothing. I just wanna get rid of it. What is it called? Oh, it's called sub. It's not called replace, it's called sub. Oh yeah, it's been too long. It didn't work. Oh, okay. Why didn't it work? I think we print it after the substitution, so you have to save it back on top of line. Now we were able to get rid of the SP, the or, whatever was in between the or bars and the next or bar. So this is more flexible than like a find and replace on most programs because you can't use stars in the same way you can here. So this is just an example where if you needed to rename something, you could. Other thing you can do is back references. So what if I wanted to keep this part in here? I still wanted that accession number, but I wanted it to be on its own line. And I actually don't know if I remember enough about how to do this to do it right. So what if I just wanted to pull out that accession number? That's going to save the accession number and return only that. So this is called a back reference. And so that is printing. What do I do with the back reference? I can't remember. Oh yeah, so that got rid of the SP, the or, and the other or, and pasted it back in. I think that's what I did. Let's look at that. No, I got rid of it entirely. How do I save it and print it? Oh, well, I can't remember. Somehow you can use back references and actually save pieces that you pull out and put back into the string. So you could like split out, this is a column and this is a separate column, and get rid of the SP or and the other or, and then have two columns. That would be the goal of what I was going to try to do here, but I can't remember how to do it. That's like the type of thing you can do with regular expressions. They're really awesome. I end up reading the documentation every single time I try to do a regular expression, just because they're pretty complicated, but the documentation is often, it's reasonably good on the Python website, but there's lots of like good blogs and people who have posted answers on Stack Overflow and places like that. So if you're trying to do something very particular with regular expression, you can also find lots of great examples online. But yeah, if you get deep enough into the regular expression syntax, you can do lots of really cool things. I do not expect you to understand back references, considering I can't even remember how to do them. Or really any of this, like the part where I started on working on the blast file, you don't have to understand any of that. Our homework will deal with some very simple regular expression examples. So don't worry too much about becoming an expert if this is not what you need for your research. Any questions? All right, let's leave it there. we'll start on RNA-seq on Wednesday. And I will post the homework on Wednesday and try to get all your current homeworks graded by then. Right. Feel free to stay after today if you want help with your homework that's due on Wednesday. That would be bad if it didn't work, right?